like to review this one part of our schedule here. So let me get my pointer. So if you guys remember, we had Adam, do you remember how many square foot that parking lot was? I can't remember. So we have a big parking lot, guys. I don't know if it's 20 or 30,000 square foot parking lot. So we did lights, and you guys imported them for the CAD into Visual. You dropped your fixture in the parking lot and ran the calculation, and then after that you export it back into Revit. This chapter basically is summarizing the stuff that we did. So list the important consideration lamps. When we talk about the lamp consideration, obviously our project Adam was LED, so we're really way ahead of this chapter. If you don't want to spend the time on LEDs, the fixture, the lamp of choice is high intensity discharge. High pressure sodium or metal halide is the fixture of choice if you're outdoor in a parking lot, if you don't want to use LED. So we talked about the consideration, guys. Talked a little bit about what type of consideration you have to take into account when you are, or factors to take into account when you select the lamp. The luminance values for the site, we guys, I can't remember, was it 5:1 average to minimum ratio that we wanted to do, and we met that criteria when you were running your calculation, Adam. Then power limit, we have a power limit and power demand for the lighting side. This is, Adam, you did this one yesterday. You guys are working on it this week, which is ComCheck. We use ComCheck to see have we met the energy code criteria for the site. And then laying out your luminaire in the parking. So locate luminaires for the site. And then the last thing, what type of control are you supposed to use? Control for the site lighting. So does that make sense, guys? Selecting the light, laying out your light. How do you control the light? Which we use did we use timers or? For our project, we selected timers. Power consumption, guys, or energy code. We did ComCheck for this project. So these are the consideration that you have to take into, or the factors that you have to take into consideration. So, Karen, when you are selecting a lamp for the parking lot, we selected the LED for you. If you were not to select an LED, when you start working on a project, here's a few factors you have to take into consideration. How much the amount of power the lamp will require to provide the needed light. The power consumption, how efficient the light is, how much lumen per watt this fixture is going to be giving you. Obviously, the more lumen per watt, the more efficient the fixture is. The color that the lamp is creating for you, color discrimination or color identification, guys, is a big deal. So if you want to be able to see your car, blue car from a green car, you need to have a fixture like high intensity discharge metal halide that can tell you that this is a green, not a blue lighting fixture. So, and we talked about this one, if you guys remember, in the commercial project. We did the whole, what is it, almost 8 weeks or 12 weeks almost of lighting. And when you put a lighting fixture, Karen, and you become a project manager one day, you're going to be maintaining this fixture for 50 years, right? The fixture, at least the layout and the fixture, you're going to be maintaining it for 40 to 50 years, changing lamps and changing ballast. So you want to put it in a place where maintenance will be kind of not high maintenance operation to maintain these electrical lights. Any comments, guys? Any questions about selecting the lamps? How efficient the lamp is, how good the lamp in distinguishing between colors, because we need to know certain colors distinguish between cars, and also how much it's going to cost us to maintain this lamp over the life of this lamp, right? Of this fixture, which could be 40 years, changing the ballast on the lamps. You don't want to put it in a place where it becomes high maintenance. Okay, so that's selection. Then you get into the power control or controlling the light. Then when we laid out our fixture, guys, in the parking lot in Revit, then we went inside and we put a couple of timers or contactors to control them. So when you do power control, you can have toggle switches. You're looking at them. Smaller control requirements are minimal. Typically, you don't want to do toggle switches on parking lot lights. If you have large number of lights, you're dealing with contactors, Adam. And if you graduate from Dunwoody, you don't know how a contactor, after you guys have been with us now for how many? 2 years? I asked me for a refund. We cheated you. If you don't know what a contactor is, guys, here's contactor, 3-phase contactor. There's a 12 right in here. and you put whatever control system is that you want, and you bring 120 here, and you're going to burn these equipment as say 480/277 lights, and all these guys goes to different lights. All these will go to different lights, and you bring a neutral here, and you pick them like this. Here's what they do, Adam, on bigger systems. Here's what they do for bigger systems. Lamp, say I'm going to put say 10 lamps here, 10 lamps here, 10 lamps here. They're big enough with the size and the watts. Here's where they use guys for parking lot, bigger parking lot. They have a contactor like the one we use in the motor, except they're called lighting contactor, made to work with lights, high intensity discharge lights. These are called lighting contactor. That's kind of the high pro, like when you go around, we drive around the cities here, and you see all these parking lots. Good morning. And all these lights, major parking lots, guys, are controlled by lighting contactors. It's one step above timers. The timers also has a contactor. And what drives these contactors is a timer, atomic clock, computer. You can make a computer driving these contacts. Okay, so that's sometimes they control in certain areas, Derek, they control the panel, the lighting panel. So they have a contactor on the lighting panel, and they turn on and off that whole panel, which all the lights come at the same time. So any comments, guys, about lighting control? So lighting control can be manual, toggle switch. Forget about it when it comes to commercial industrial parking lot. The next step, guys, is to have timers. That's another good step. And a bigger step is to have contactors. They use a lot of contactors, lighting contactors, to control the lighting fixture. So that's our option. Operation of system. We talked about manual, guys. If you use a manual, as I said, it's not an option, but low cost. You have to perform the work. So costly and unreliable because you have to turn the light on and off manually. Of course, fully automated system, you're using magnetic lighting contactors, and of course you have to pay for the contactors, so high cost, minimum maintenance, and reliable. And minimum maintenance is kind of a minimum maintenance cost, but reliable. So you can have a bunchable contactors, Derek, that you can drive. You can monitor your lighting system through your laptop. They have a building automation system, guys, that can monitor the lighting, if the lighting in the parking lot is on or off. So the capability is endless. When we went to Davis & Associates, I don't know if you guys remember talking about all these technologies that you can use indoor or outdoor. So fully automated. For our project here, we use a couple of timers since we had, maybe 8 fixtures or something like this outside. So we used 2 timers to control. One timer will be controlling the parking lot light, and the other one is the perimeter light. Okay, now moving into the most important things, guys, in any lighting fixtures, including the site or inside or outside, is the source of the light. The source of the light, you guys, we spent a whole class last year talking about lighting science. And we talked about these are, in addition to LEDs, of course, which is what we use in our project. We use LEDs. In addition to LEDs, you can use incandescent. Of course, this is not an option. Fluorescent in Minnesota, not a whole lot of good option, cold weather. So the only option probably will be for us here is high intensity discharge, mineral halide, or high pressure sodium. See, these are the 3 types of lamps that you can use in addition to the LEDs. And the types and the shapes and what's not, as you guys know, when we did the lighting last semester, there's hundreds of these types. Okay, a little bit of reminder, Adam. You're going to hear me talking about this once and forever. Then you're going to kick you out of here, and you're expert in lighting. Here's what the incandescent lamps, guys, you're familiar with, works. The Edison type lamps. There is a wire filament. You energize it with inside of out. That vacuumed, or there's empty of air, or they stick a little bit of enriched gas. They have a filament, which is a little bit of a heater, basically, coil of wire, and then when they energize this baby, it emits the lights. They energize it, and it will emit the light inside this bulb. Any comments, guys? Any questions? Very easy. You have a coil like this. You energize the coil. And when the coil is energizes, it glows and creates light. Then they treat it a little bit, and they call it halogen type. Put some halogen, guys, halogen type light. tightly wound, the same things. They treat it a little bit, make it better. Tungsten filament coil. What this one does is typically increases the life expectancy of that fixture, doubles the life expectancy of that fixture. Still a very bad choice if you're for an outdoor or even indoor. So that's your incandescent lamp. Fluorescent lamps, you guys, we talked about these, have two filaments, one in each end. What they do is you energize these and they start shooting electrons and bombarding the phosphorus that's coated, the inside of the bulb is coated with, so they should create an arc, right? You energize these filaments, you create an arc, they start shooting at each other, and creating bombarding the phosphorus, and by that, when you create an arc, we have a ballast that maintain the arc, and that arc will be converted through the phosphorus, guys, into a light that you and I can see. You can change the color based on how you treat the phosphorus and what's not. But that's another source, not option for the site, obviously. Longer life, then of course the incandescent and fair tolerance for voltage swings is still an option, guys, in indoor, but outdoor typically is not a whole lot of good option. High intensity discharge, Matt, my friend, these are the same thing. They create an arc and they maintain an arc, and bigger arc though. They put mercury to maintain and glue the arc, obviously, because of environmental choices and three-legged frogs, Karen, because you and I care about the environment. Frogs are having 3 legs instead of 4 legs, so we don't use it anymore. Your two options, guys, are either metal halide, if you guys remember in the commercial project, metal halide, or high pressure sodium, depending on the gas that you put inside that bulb. And preferred over mercury, of course, metal halide is your choice. High pressure sodium is good, color rendering a little bit poor, but color discrimination can be enhanced. The last one, which is low pressure sodium, I don't know if you guys remember talking about this one a long time. It has an excellent output of lumens per watt. The problem with this one, it's hard to see between colors, to discriminate between colors. So you might not be able to see your fixtures. You might not be able to see your fixture. Your car in the parking lot. Any comments, guys? Any questions? Questions about these? And I know these are, Derek is a review of what we've done in the fall. If you guys remember when we talked about these different type of lamps. Okay, here's a lamp preference data. There will be on the test, guys, if you don't want to worry about, there will be a question directly related to this table. We'll ask you compare which fixture is the best fixture in terms of multiple things. For example, I'm going to take, guys, high pressure sodium, and in terms of watts per hour, I want you to look at the watt per hour, 250 watt rating, lumens rating. Look at your lumens rating. You can get this amount of lumens, floodlight, total watts that you can get, and the most important thing is really this one, the life. You can get almost 29,000 hours out of that. Lamp length is not a big deal. Lamp load, how much load you have in each one of these. So the lamp life is one of the most important things that you can get out of these fixtures. Total watts, lamp life, lamp length, and lamp load. Okay, so these are a few things. So of course, the longer they live, the better the lamp will be. The longer they live, the better the lamp will be. In fact, we have a better table than that one. Okay. So that's basically the type of the fixture that we're going to use. And most likely, like I said, if you're not doing LEDs, Karen, your choices, you're looking at metal halide, high pressure sodium for the most part if you're doing parking lot. Any comments, guys? Any questions? It's a crime, Derek, my friend, to leave here not knowing if they tell you we're going to do a lighting and pick a lighting fixture. It's a crime to go there not knowing that, and we're not going to do is LEDs. What type of fixture, the fixture of choice when you do a parking lot, you're going to have metal halide, high pressure sodium. These are kind of the optimum design for outside, taking into consideration, guys, the lumens per watt, taking into consideration the life expectancy of the fixtures, the performance of the fixtures. So like we did, if you remember, Derek, when we did the commercial project, that was basically what we chose, metal halide or high pressure sodium. Low pressure sodium, guys, the problem with low pressure sodium is color discrimination is zero. So you can't tell from green from blue. You don't want to put this one in the parking lot. Unless you are a rich guy like Derek and can squeeze, you can start your car from a distance, right? Oops, did I say that? Every time you click and you start your car here, you make me jealous. So you don't have to worry about finding the car, right? Color-wise, you just click on it. But anyway, it's still good to be able to see your car. Even with good color discrimination, I still can't find my car in the parking lot. Okay, light distribution. When we do light distribution, and I want to remind you, my friends, that we did a whole semester about lighting. The single most important, look above your head or outside, guys, is the lamp. What type of lamp are you using? Are you using high intensity discharge? And what type and shape of lamp are you using? Fluorescent? How are they sending the light in 360 degrees, tubular fluorescent lights? So the type of the source, high intensity discharge, LEDs, and the shape of the fixture. That's the most important thing. And we decided, Karen, that outdoor, we're going to be using LEDs for us. The second thing is reflectors. Reflectors, guys, will direct the light to the location that you want the light to go. Otherwise, the light will go wherever it wants to go, right? So you need reflectors. So that will reflect the highest reflectivity. So reflects, like look at above your head, Derek. All the lights is going up, shoot down to where we don't want it to hit the ceiling, right? We want it to shoot down, down on the floor or in the working level. Same thing outside, guys. In the parking lot, we want to lit the parking lot. We don't want to lit the sky. So you have to redirect all these lights directly to the parking lot. Okay, lenses. Lenses will focus, guys, all these light to wherever you want them and to distribute. We have glasses, plastic, designed to redirect the light and distribute the light. So if you want to evenly, the lenses or the louver lenses, you're looking at them right there, guys. It take that light and distribute them evenly to the square foot of the parking lot. Any comments, guys, about lighting distribution? And you guys are very familiar with the foot candle that we have been doing. Okay, so that's light distribution. Lamp efficacy, Adam. Lamp efficacy, you yesterday did a comp check for us. So when we did a comp check, the single most important thing why we do a comp check is because we need to make sure that we are efficient. We don't want to burn more energy than we need to. So the way they do it, guys, they take the lumen divided by the watts. Lumen per watt. The higher lumen per watt the fixture, the more efficient the fixture is. When the lamp is ballasted, meaning it's used ballast, you also have to take into consideration the watt that will be taken to cook the ballast. You guys, if you remember from all these T8s and what's not, you can find a 32 watt, guys, two bulbs 32 watt, but that doesn't mean you just multiply them and that's the total watt you have. There's a little bit of energy will be burned inside the ballast. So you take the energy also taken into consideration, burned inside the ballast, if that fixture has a ballast. Any comments, guys, any questions? So take the lumens divided by the watts, they'll give you how the efficacy of this fixture, meaning how efficient this fixture in terms of producing lights for the least amount of power, producing the maximum amount of light for the least amount of power. Any comments, guys, any questions? We talked about efficacy last semester, so this is, like I said, probably review. Lamp color characteristics is a big deal, guys, because you can make things look different based on the type of the light that you put on them. So the objects will look differently based on their own color and based on the color of the light that you're throwing on them. The color of the light, we have no control over the color of the objects, but we do have control direct over the color of the light that we throw at them. So that will decide something called color rendering index. If the color rendering index, guys, is high for the fixture, that's a great fixture. It can discriminate between colors. If the color rendering index is low, this is a poor fixture in terms of color discrimination. So you can't put it in a place where you want to discriminate between colors. To be seen should be viewed under the lamp before selection. So Exact colors, guys, you have to, if you want to see the exact colors, you have to be very careful. If the color is a big deal, parking lot, typically, it's not a whole lot big deal. You need to be able to distinguish between the colors for your cars. But say if you're working on a lab, like for example, the manufacturing floor that we have, now they're working with chemicals. Wouldn't you think they would need to be able to see the color of the chemicals or the color of the labels on the chemicals? That's a major thing. That's a safety hazard. So color rendering index, if you're doing manufacturing, guys, chemical equipment, nuclear, whatever, that's a big deal. So color becomes more important than seeing my car in the parking lot. So you need a fixture with a very high color rendering index. So color rendering index, remember, color rendering index, higher, better, but most expensive, of course. All right, here's a few things, guys, about the color rendering index. Typically, if you guys remember from last year, we talked about the incandescent one is accepted by many as the color standards. It's considered warm white. Blue will appear somewhat gray though on it. So I don't know if you guys remember, 100% is in the mid, like outside in the summer. I think that's what we did in the summer in Minnesota, outside at noon. That will give you 100% color rendering index under the Mother Earth sun. So you can see the exact color of people, right? And you can see that that's the maximum. That's 100%. Now, 0%, I don't know, at night when there's no light. That's 0%. Everything looks black. So that's the kind of the extremes. Mercury Deluxe, guys, has a cool greenish color. Reddish and oranges will appear somewhat gray. So this is just a few things about color rendering. Fluorescent makes any degree, so there's a variety of wide lamp colors that can do a rendering. Plus, you can do a lot of rendering. Color rendering is good. Metal halide, similar to mercury. So mercury, like I said, greenish light, red and oranges will appear a little bit gray. Low pressure sodium, look at that. Has an orange yellow light, permits good color discrimination except with reds and blues. And high pressure sodium, I think these should be flipped here. Sorry, these should be flipped if you guys. So low pressure sodium is no color discrimination whatsoever. No color discrimination. Permits no color discrimination except with yellow objects. Everything looks yellow. The low pressures, that's why we don't use them. But Adam, a good application for them in the highways. So if you're driving at, do you speed? Who speeds here? Derek, do you speed? Say if you're going down 94W and the speed limit is 60, well 55 here, but say 55 and you're going 65 miles an hour. Do you really care about the color of the car next to you? Do we really look at there and distinguish between colors? You need to be able to see the object. You see it clearly. Does it matter if it's blue or green as long as I clearly see that there's a car in front of me or a car next to me? Does it matter what the color is? Not a whole lot. So that's a good application for these. You throw them in the highways. Now tell that one to a police officer who's chasing a car. That's a whole different story. But for the most of us, you're driving at night at 85 miles an hour or 65 miles an hour, guys. I don't care about knowing if it's gray or blue next to me, right? I need to be able to see it. And this fixture will allow you clearly to see the objects so you can avoid them. But you might not be able to see what the color is. Who cares? Does that make sense? See the application of that particular low pressure sodium. So I can't emphasize these, the description guys here are flipped here. So I'll adjust that one. Okay, the last thing guys is lamp maintenance. It's a big deal. How big of a deal is to maintain the lamp, guys? Strongly sensitive to lamping. Lamping can be expected to fail. Lamps will fail, so you have to do re-lamping, guys. How difficult it is to replace these lamps? Do you need a crane to go there, or what do you need? A ladder? What type of a tool you need to replace these fixtures? So you don't want to put them in a high place. When it comes to longevity, incandescent lamps is not a good fixture to put. Short lifetime expectancy. Fluorescent will go after it, and metal halide is the best in terms of long after the LEDs. Life expectancy, guys, it goes from a thousand hours for incandescent into 24,000 hours for fluorescent, and LEDs is in the 48,000 hours and what's not. So in terms of the long, that's why we go LEDs, guys. Well, the jury's still out on the LEDs. The problem is they're supposed to live longer, easy maintenance, consume much less power for the same amount of more light. Okay, so the last thing is, after we maintain the fixture, pick a fixture that's least maintenance, live long, easy to get to change. Illuminance selection. The exterior areas, guys, you have to depend upon the type of the activity that you can use, and of course, International Illumination Society of North America will, or IES, will give you guys a recommendation for different types of candle, foot candle that we can use in different applications. And I have a few here. So, for example, parking lot minimum, you need a minimum of 0.5, roadway 0.6. If you're doing storage, you need 20. Pedestrian, you need 0.9. These are your minimums typically for these areas. Minimums for these areas that you can maintain in order to see properly. Power limitation. So first we know how many foot candle, guys. All this information were given to you guys for our project. We gave you the maximum to minimum, if you guys remember, for our project to do. Then the second thing is, of course, is the energy code. You need to pay a lot of information to the energy code. ASHRAE, Adam, this is what you did yesterday. I don't know if you picked the right one, but we will see. You have to pick ASHRAE 2004, I believe, is what we're doing right now in Minnesota. That's what we did last project. This one should have been picked the same way. Otherwise, we just flipped it to the right one. And it will give you guys different allowances that you're allowed to do in different areas. For example, if you have a parking lot, 30 watt per square, roadway 2 watt per foot, storage 0.4 watt per square feet, and pedestrian you can 30 watt per foot, linear foot. Any comments, guys, about all these? So Derek, my friend, when you guys by the end of the week when you do your energy code, that's basically what you're going to be picking up, something similar from depending upon the ASHRAE, which ASHRAE code you're going to be using, which is, I believe, we're going to be using 2004. Okay, then you drop your fixtures, Karen. You drop your fixtures typically 30 foot with a 3 foot pole base for it. Isofoot candle curves, you guys remember that, how we did all these curves, and this is a double-headed one, and it will give you all these points will connect, all these curves connect all the points that have the same foot candle. And if you guys remember, we set one at 0.5. So we need to, this is the minimum that we need to see. We're the minimum for these fixtures. We drop them. Here's how we drop them, guys. You drop your fixture at different, here's this, they're setting the minimum at 1.1. 0.5 is the perimeter. Here's another minimum. I don't know if around all the fixtures that they want to maintain. They want to see 0.56 here. Every time they intersect each other, if you guys remember what we did, they add each other's up. We did a lot of calculation last semester on adding the foot candle coming from different fixtures. If you have pedestrian light, guys, typically if people are walking right here, here's Adam walking in here. So what you do, guys, is they put a fixture. Here's a recommendation for the height of that fixture where it lit that area for people to pedestrian sidewalks to see. Here's another recommendation for these. And then at the end, of course, you need to wire them. You have two options. Either you have a UF cable, directly buried cable, or you can have wires and conduits. But every time you go under a sidewalk or under a parking lot or what's not, especially sidewalks, you need to go with a conduit for ease of installation and maintenance. So you have UF cable or you can use conduits, but if you use a cable, every time you go under sidewalks, guys, we typically drop a UF a conduit there. When you select your conductors, if your conductors, typically, guys, you don't want to use less than number 10 outdoor. I'm going to be looking at yours, guys, when you specify it. No number than 10. Typically, number 8 is very common. And the reason, Adam, not because of the load, when we put a fixture outside, the reason we put a bigger conductor, not because of the load, it's because of the voltage drop, conservation. So we always pick a bigger conductor for if you have a 20 amp circuit, typically I can use number 12 with it, right? To number 12 done. So we go to number 10 or number 8 because of voltage drop conservation. Okay, selective control of the lighting and the various activities. Also, we'll decide how we're going to be wiring these systems. We talked about the control, guys. We have photocell control. We have timer. This is timer clock. That's what we did. You can dim that area, typically not parking lot. Or you can have override switches. You can put them in manual or auto or what's not. So that's your lighting control system. Any comments, gentlemen? Any questions? So that's a quick review, Kieran, of everything that we have done last semester, if you guys remember, about lighting. So when it comes to outside lighting as well as inside that lighting, guys, you need to pay attention to color rendering or rendition. Maintenance is a big deal. Luminance selection of wood candle is a big deal, and of course, luminance replacement or maintenance is a big deal. All these will point right now, Karen, to the LEDs. All these will be pointing towards using LEDs in this day and age. It used to say high intensity discharge, metal halide, high pressure sodium. For the most part, we're showing LEDs. Any comments, any questions, gentlemen, ladies? Boy, I tortured you. Okay, so like I said, this is a review, guys, of what we have done. This is the last time I'm going to hear Chad before you graduate talking about lights and light selection. I hope you will pick the best out of this chapter and we'll move on. Okay, we're going to be leaving, guys, in 5 minutes. We're going to be doing touring Allianz. I'm driving you guys. You're going to be seeing, guys, a data center. You will be looking at the computer load with racks. You're going to look at the PDUs. Please pay attention to the PDUs when you go there. Power distribution. Pay attention to the crack units, the cooling units that they call the UPS system there. We're going to tour a computer room. We're going to tour the UPS room. We're going to tour the, what else we're going to tour? The battery room, as well as the electrical and mechanical rooms on the roof. Okay? So in 5 minutes, we're going to be going there. Thank you.